For this week's experiment, we were given seeds and we had put them in the petri dishes with a saltwater solution to test the effects of salts growing, how salt affects the growing of the seeds, and furthermore affects growing of food for the world. Now, I grew up in Iowa and Illinois, so I kind of understand the importance of soil and good soil and how it affects the farms. For some people, they may have never seen a farm or know how farming works. There are some things about farming I know absolutely nothing about, and we've talked about that before. We had 5 different types of soil levels. Salt levels in the soil. We had 2%, 1.5, 1.5, and 0. Now, in doing the experiment, we took 10 beans and we put them evenly into the dish and then added the water. Now, every day about the same time, we added more water we weighed it to see the difference and added more water to equal it out to what it was the night before if needed. After the experiment was done, we looked at the data here, and I'll show the data here in a second. And the germination of the seeds, how they started to grow, if they did. The higher the level of the salt, the less growth is what I found. Of the 10 seeds in the 2% salt solution, no complete germination, no incomplete germination. As a matter of fact, they look like they didn't been touched at all when I put them in the water. At 1.5%, we had 0 complete germinations, and we had 5 incomplete and 5 no germinations. And when I say incomplete, they grew a little bit, enough to get them into that category. At 1.0%, we still had complete germination at 0, but we had 7 incomplete germination, and we had 3 no germination. At 0.5, we had our first complete germination. At 5, we had incomplete germinations, and we had 4 no germinations. Now, when we went with 0 salt water, we had 4 complete germinations, 4 incompletes, and 2 non-germinations. When we looked at, excuse me, pull the next page up. Here, let me show you why I got it up. I'll show you the levels. Excuse me here. As we talked about, you have the 2.0, 1.5, 1.0, 0.5, 0.5, and 0.0. Now, let's go back to where we were. Sorry about this. Fat fingers hits everything. When we looked at the effects, the first thing I noticed was, the list of experiments. The first thing I noticed, we're using distilled water, and we talk about it in the 5 questions they ask us to fill out at the end of the experiment. The purpose of using distilled water. Luckily for me, I use distilled water every night for my sleep apnea machine. Basically, distilled water is a purified water in which they vaporize the water. It removes the chemicals from the water and then is purified back into water, leaving the chemicals behind. This helps the experiment because there's no other chemicals other than what we put into it, the salt water mix. So there's no fluoride, there's no iron, there's no whatever calcium buildup, if you even want to put that in there, to affect the seeds. Now, granted, there could be stuff in the ground other than the salt levels that could affect seeds, but for this experiment, we didn't go with that. The first question asked, why is salinization a concern for the agriculture around the globe? As we found out through the experiment, higher levels of salt increase the risk of crops not growing. In the example of 2%, there was no growth of the seeds at all. Now, if the test had been longer, could have grown, yes, but at the same time, it also could affect when you plant the seeds and when you harvest the seeds. Like I said, we talked about 10 and 10 seeds in a petri dish. Imagine if this had been 40 acres, as I wrote down. How much longer would that have affected the soil levels? Why were the petri dishes containing the beans weighed at 24-hour intervals? Basically, for me, it's the same thing as taking your medicine the same time every day or the same every night. It creates a balance in the experiment. The more time you elapse between weighing them, the more salt will absorb the water. Or if you weigh them too soon, it doesn't give time for salt to absorb the water. So it's like it's a balanced equation. What was the minimum salt concentration that affected the bean germination? At 1.5, I had some incomplete seeds. Based on your results, would you classify the bean species used in this experiment as a halfophyte or a glyphosate? Like I said, I apologize. I have a speech impediment. There's some words I cannot pronounce. I pronounced it as glyphosate, as they can grow in minimum salt levels. When we talk about other examples in the experiment, the one thing when I completed the graph, it didn't show up in the there was no place to put it in there, so I kind of guess you could say it was something that needs to be worked on for the next experiment if needed. One thing that excuse me 1 second here, I want to get the questions back up. One thing it says the groundwater salt concentration at 0.5 is an appropriate water source for irrigating field beans. It says the statement is false. Groundwater with a salt concentration of 0.5 is an inappropriate water source for irrigating field beans and result in incomplete germination. This kind of, I don't know. I could have grown, yes, but at the same time, grow up in Iowa, Illinois, you have your harvest times. Now, if it's something like a West Texas, does it affect it better? Where you have cotton seeds, you have longer seasons to grow, or you have more time to grow before a frost comes in and wipes out your wipes out your harvest. That's something could be debatable. Like I said, I'm not a biologist, but I would think that maybe with a little bit higher of a salt level and you have more time between frosts in the growing season, could it help? That's something you need to think about. I'm kind of curious myself. When we sit here and we look at man-made objects, the first thing I honestly look at is the soil level and the pollution and how we can stop it. Like I said, obviously dumping soils or burying hazardous waste is, just the worst thing possible you could do for growing food. The other thing is digging too deep, or purposely putting salt in the ground. For an example, when I lived in Tennessee, we had a tree we cut down, and I was trying to figure out how to get rid of the stump because it was like $800 to have a stump removed, and somebody told me just drill a hole in the stump and pour salt, and it would kill the roots and it'd be easier to take up. Luckily we did, and we ended up just blowing it up, which is a great story for another time. But if I would have put salt into the stump, how much would that have gotten to the ground? I mean, granted, it wouldn't have affected the world, but if, how far out from the tree would the salt have grown or affected the soil? That's something I'd be kind of curious to know as well. That's it for this week. Hopefully I explained everything, and hopefully my lab partner back here wasn't snoring too loud. She's she's kind of worthless, but she's a good dog. So thanks again.